Hey guys, welcome back to StatsB. So we've learned about how to calculate means and standard deviations and also what they tell us about the data. So by using both the mean and standard deviation, we can actually find the proportion or percentages of the total observations that fall within a given interval about the mean. This section we will discuss the empirical rule. So the empirical rule is only specific to bell-shaped data or bell-shaped distributions. So this essentially means that it only holds or works for when your data has a bell-shaped distribution. The empirical rule states that for a bell-shaped distribution, approximately 68% of your data will lie one standard deviation from the mean. And then 95% of the data will lie two standard deviations from the mean. And then lastly, 99.7% of the data will lie within three standard deviations from the mean. Alright, so let's put this in simple terms using an illustration. So we know that with bell-shaped data, the area under the curve is symmetric about the mean, and therefore, if we add one standard deviation to the mean, we get a value to the right of the mean, and then if we subtract one standard deviation, we get a value to the left of the mean, and these two values would give us an interval that has 68% of the data. Now, using the same logic, if we add two standard deviations to the mean, we get a value to the right of the mean, and then if we subtract two standard deviations from the mean, we get a value to the left of the mean, and then these two values would create an interval containing 95% of the data. And then finally also, same logic, if we add three standard deviations to the mean, we get a value to the right of the mean, and then if we subtract three standard deviations from the mean, we get a value to the left of the mean. And these two values would consist of an interval that has 99.7% of the data. Alright, that's just about what you need to know and master about the empirical rule. But furthermore, which can be quite useful when solving problems, are the percentages or proportions due to symmetry. So because we know that the distribution is symmetric about the mean, hence there is an equal amount of data that lies to the right of the mean and to the left of the mean. An example here, if we look at the 68%, we know that if we were to break it down into half, 34% would lie to the right, and then the other 34 would lie to your left. Same logic applies to the 95%. If we were to add the 34 and 13.5, that would just be half of the 95%. And also, lastly, if we were to add the 34%, 13.5%, and the 2.35%, this would amount to half of the 99.7%. Alright, so I have here an exercise that will help us understand the concept of the empirical rule and also the different ways in which we could apply it. So we have here the price of all college textbooks that follow a bell-shaped distribution with a mean of $105 and a standard deviation of $20. We are then asked to use the empirical rule to find the percentage of all college textbooks with their prices between $85 to $125. Secondly, $45 to $125, and then lastly, $65 to $165. So we need to find the percentages. So first things first, what I would look for is the fact that if the distribution is bell-shaped, and yes it is, we are given that the distribution is bell-shaped, and then we are also given a mean of $105 and then a standard deviation of $20. Alright, so guys, before I dive into solving the actual questions, what I like to do is kind of fill in information into this distribution to help me remind me of the empirical rules. So we know that the data is basically centered around mu, and then we also know that 68% of the data lies within this pink region. And then I go on and add on the one standard deviation away. So it is one standard deviation away from the mean. So this side, it's the mu minus sigma. Right, and then for the blue area, which is 95% of the data, we know that the interval there is 2 standard deviations away, and therefore I add on mu plus 2 sigma. On this other side, I add on the mu minus 2 sigma. Right, and then finally for the yellow part, this is where we have the interval where the data lies 3 standard deviations away from the mean. So put it there just to remind ourselves, mu plus 3 sigma, and then on this side we have mu minus 3 sigma. And then another important thing is I also want to put in the percentages or proportions due to symmetry. This becomes very useful depending on the question. So I'll go on and start with the pink area. This is 68% of the data, and if I separate it into two, I get the 34% on each side, right? And then for the blue part, we got 13.5%, and then 13.5% on this side. And then for the yellow part, this is where we had got your 2.35%, and then this part is 2.35%. Alright, so now that we have this information, we can go on and try to solve this. So for our solution, okay, so first of all, before I even dive into solving the question, let us figure the intervals for the 3 proportions or percentages. So let's start off with the 68% proportion. So this is where the data lies 1 standard deviation away from the mean. So we have your mu plus minus sigma, right? And then this should give you $105 plus minus $20, right? This equals to, if you put this into your calculator, you should get $85 and $125. So what this essentially means that 68% of the data lies between $85 and $125. So basically, the textbooks that cost between $85 to $125 is 68% of those textbooks are in this price range. And then let us look at the price range for 95% of the textbooks. So this is where we have the interval lying 2 standard deviations away. So it's mu plus minus 2 sigma equals to $105 plus minus 2 times $20, and then that should give you an interval of 65 if you put it in your calculator. So 105 minus 2 times 20 is 65, and then 105 plus 2 times 20 should give you 145. Great. So this basically means that 95% of the textbooks lie between the price range $65 and $145. And let's look at the final proportion or percentage, the 99.7%. This one is where we have the interval that is 3 standard deviations away from the mean. So that is your mu plus minus 3 sigma. That should give you 105 plus minus 3 times 20, and this should have given you an interval of 45 and $165. So what does this mean? Again, this just means that 99.7% of the prices of the textbooks will be between $45 and $165. Alright, cool. Now that I have these intervals that correspond to 68% of the data, 95% of the data, and 99.7% of the data, I can go on and solve the real question. But before that, let us put these values into our graph to help us answer the question. So we know that for the 3 standard deviations away, the interval is 45 up until 165. So that's 99.7% of your data. And then for the 95%, the interval $65 up until your $145. And then finally, for your 68% portion, the interval is $85 and 125. Cool. So to answer our first question, we are looking for the percentage of all college textbooks with their prices between 85 to 125. So we go back to our graph here and look for 85 and 125, and then we match it up to the region that it corresponds to. And we can see it is the pink region which corresponds to the 68%. Hence, our answer here should be 68%. So what does this mean? This essentially means that 68% of the textbook will cost you between $85 to $125. And that is essentially the interpretation of the 68%. And then secondly, we are looking at the interval between 45 to 125. So look for 45 and look for 125 in your graph, and then you just add on these small percentages that correspond to this interval. So adding them together, we get the 2.35%, right, for the yellow portion. Then we get the 13.5 because we are adding all these percentages from 45 to 125. Be very careful. Right. So we have 13.5% plus 34%, which is this pink region, and then another 34% for this pink region at the end of this 125, and then you should get an answer of 83.85%. And how do we interpret this 83.85%? So this essentially just means that 83.85% of the textbooks will cost you around $45 to $125. And then finally, we want the percentage for the $65 to $165. So again, we look at our graph, look for 65, and then look for 165. So yes, do the same thing. You just add up all of these percentages that lie within these two numbers, 65 and 165, and put those into your calculator. So you would firstly have the 13.5% plus 34% plus another 34% plus another 13.5%, and then finally that corresponds to this 165 is the 2.35%. And then this should give you a total of, or bring you to a total of 97.35%. And then again, how do we interpret this whole thing? So this basically means that 97.35% of the textbooks will cost you between $65 and $165. I hope this makes sense, and if you have any question, please pop them down on the comment section. I will try to answer as quickly and as soon as I can. So this brings me to the end of the empirical rule. So another result for this question, a question that might have popped into your mind is that what if the distribution was not bell-shaped and it was maybe negatively skewed or positively skewed? Then how would we find proportions? Alright, stay tuned for a video called the Chebyshev's theorem that will guide us through what to do when our distribution is not necessarily bell-shaped.